Hi friends, welcome back to our YouTube channel. Today we have to discuss about flowchart of addition and subtraction with signed magnitude data in computer architecture course, computer organization course, computer organization and architecture course. It is one of the important concept. First, we have to perform the two operations. The first one is add operation and the second one is subtract operation. When we are performing the addition operation, we require two numbers as input. The first number can be called as agent. The second number can be called as addend. For example, we have to perform 2 plus 3. The first number is 2, that can be called as agent. The second number is 3, that can be called as addend. Agent is stored in register A and addend is stored in register B. Okay, next one. The sign bit of A can be denoted by AS and the sign bit of B can be denoted by BS. Okay, first we have to compare the sign bit of A and the sign bit of B. For that purpose, we have to use a comparator. In that comparator, we have to use the exclusive OR gate. Okay, now we have to compare the sign bit of A and B. So A sign bit value is 0 and B sign bit value is also 0. Next, A sign bit value is 1 and B sign bit value is 1. In between them, we have to perform the exclusive OR operation. So whenever we are performing the exclusive OR operation between the signs of A and B, when both bits are same, the output of the exclusive OR gate is 0. Here also both bits are same, then the output of the exclusive OR gate is 0. Here, so the output of this exclusive OR gate is 0 whenever the sign bit of A is equal to the sign bit of B. Here the sign bit of A is equal to the sign bit of B. Then what is the output of the exclusive OR gate? We are getting 0. Okay. Whenever we are getting the output of this exclusive OR gate is 0, that means the sign bit of A is equal to the sign bit of B. We have to, at that time, we have to perform the addition operation between the magnitudes of A and B. The first number magnitude is A and the second number magnitude is B. We have to perform the addition operation. Whatever the result we are getting, that result is stored in register A. Any output carry is generated while performing the addition operation between A and B. That output carry can be transferred to the extended flip-flop E. After that, the content of extended flip-flop can be transferred to AVF. AVF is nothing but add overflow flip-flop. Okay. Finally, the result is stored in A and AS. The result is stored in register A and its sign bit is AS. So this thing can be performed when both sign bits are same. At that time, the output of the exclusive OR gate is 0. Simply we have to add the magnitudes of two numbers. The result is stored in register A. any output carry is generated, that carry output can be transferred to extended flip-flop, that can be transferred to add overflow flip-flop. Finally, the result is stored in register A and its sign bit is AS. Now, another case is, so AS exclusive or BS. When the sign bit of A and B are different. So A sign bit is 0 and B sign bit is 1. Another case, A sign bit is 1 and B sign bit is 0. Now both sign bits are different, then we have to perform the exclusive OR operation between the different signs of A and B. Then what is the result we are getting? So in both cases the result we are getting is 1. Okay. So now this case we have to consider when we are performing the exclusive OR operation between the signs of A and B. When both signs are different, the output of the exclusive OR gate is 1. Whenever the output of the exclusive OR gate is 1, we have to say that AS not equal to BS. AS not equal to BS. AS not equal to BS. At that time, we have to perform the subtraction operation. How to perform the subtraction operation? The subtraction operation can be performed by using 2's complement. So, first we have to take the 1's complement of B. We are getting B bar. After that, we are adding 1. So, then we are getting B bar plus 1. That can be added to the A. So, the result is stored in register A. If any output carry is generated, that output carry can be transferred to extended flip-flop E. While performing the subtraction operation using 2's complement, so there is no output carry is generated. If any output carry is generated, simply we have to ignore them. So at that time, so E value is equal to 0. The content of E value can be transferred to AVF. So whenever E value is 0, that 0 can be transferred to AVF. Okay. So while you are performing the addition operation, when both sign bits are same, simply we have to add the magnitudes and the result is stored in register A. Any output carry is generated, that can be transferred to extended flip-flop. That can be, the content of extended flip-flop can be transferred to AVF. If both sign bits are different, the output of the exclusive OR gate is 1. That means AS not equal to BS. At that time, we have to perform the subtraction operation. The subtraction operation can be performed using 2's complement. 2's complement we are getting by taking 1's complement of B plus 1. After finding out the 2's complement of B, that can be added to content of register A. Finally, the result is stored in register A. While performing the subtraction operation, if any output carry is generated, that can be discarded. So, E value is equal to 0. The content of E value can be transferred to AVF. Whenever E value is 0, 0 can be transferred to AVF. In this way, we have to perform the subtraction operation. Okay. Now we can go for the subtract operation. Okay. Here we have to perform the addition operation when both sign bits are same. We have to perform the subtraction operation when both sign bits are different. Now consider the subtract operation. While performing the subtraction operation, we require two numbers. two numbers. The first number can be called as minute and the second number can be called as subtrahend. Here 4 can be called as minute, that is stored in register A, and 3 can be called as subtrahend, that is stored in register B. Now 4 is stored in register A and 3 can be stored in register B. And what is the sign bit of A? That is AS. And what is the sign bit of B? That is BS. First, we have to compare the sign bits of A and B by using exclusive OR operation. So, when both sign bits are same, that means A sign bit is 0 and B sign bit is 0. Okay, so next A sign bit is 1 and B sign bit is 1. In between them, we have to perform the subtraction operation. 0 exclusive OR 0 is nothing but 0. 1 exclusive OR 1 is nothing but 0. Okay. So here the sign bit of minute is AS and the sign bit of subtrahend is BS. First, we have to compare the two sign bits using comparator. In that comparator, we have to use exclusive OR gate. When both sign bits are same, then the output of the exclusive OR gate is 0. So, output of the exclusive OR gate is 0 is nothing but AS is equal to BS. The sign bits of A and B both are same. Okay. Whenever the sign bit of A and B are same, the output of the exclusive OR gate is 0. We have to perform the subtraction operation. We already know that how to perform the subtraction operation. So here we have to perform the subtraction operation A minus B. So this subtraction operation can be converted into addition operation by taking A plus 2's complement of B. A plus 2's complement of B. How to find out the 2's complement of B? So 1's complement of B plus 1. 1's complement of B is B bar and after that we are adding 1. So in this way we have to perform the subtraction operation. A plus B bar plus 1. The subtraction operation can be performed using 2's complement. We have to find out the 2's complement for the subtrahend only. First we have to take the 1's complement, then we are adding 1. After that result can be added to the minute. Whatever the result we are getting, that result is stored in register A. If any output carry is generated, that carry can be discarded because in 2's complement subtraction operation, if any output carry is generated, that can be discarded. Therefore, E value is equal to 0. Whenever E value is 0, the content of E can be transferred to the add overflow flip-flop. That is, after performing the subtraction operation, sometimes we may get the positive result, sometimes we may get the negative result. For that purpose, we have to check E value. If E value is equal to 1, we can say that we may get the positive result. If E value is equal to 0, we may get the negative result. When E value is equal to 1, we have to check two conditions. A greater than B and the second condition is A is equal to B. Whenever A is greater than B, whenever we are performing the subtraction operation, we may get the positive result. When A is equal to B, whenever we are performing the subtraction operation, we may get the 0 result. Okay. In the first case, we are getting A is greater than B. At that time, the result is stored in register A. At that time, A is not equal to 0. A is not equal to 0 means the result value stored in register A always contains some positive value. At that time, we do not do any modifications. The result is stored in register A and its sign bit is stored in AS register, AS flip-flop. Next, in the second case, when we are performing the subtraction operation, we may get the result value is 0. When the result value stored in register A contains 0, then 0 can be assigned to the sign of register A. That means AS value is equal to 0. So, this is for only second case. Okay, this is for only first case. When A is greater than B, whenever we are performing the subtraction operation, we may get the positive result. That positive result is stored in register A. So, register A contains some positive result. At that time, we can say that A is not equal to 0. Whenever A is not equal to 0, so we do not do any modification. The result is stored in register A and its sign bit is stored in AS. Whenever A is equal to B, whenever we are performing the subtraction operation, we may get the 0 result. So, when we are checking the register A, the register A contains result. That result value is equal to 0. We have to assign 0 to the sign bit of register A, that is AS. That means we are always getting the positive result. Next one. When E value is equal to 0, we may get the negative result. So at that time we can say that A is less than B. A is less than B is nothing but A value is always less than the B value. At that time we have to perform B minus A. So guaranteedly we may get the negative result. We may get the negative result. Okay. Whenever we may get the negative result, the result is stored in variable A. Okay. Whenever we are getting the negative result, first we have to find the 2's complement of the result. 2's complement of the result is, first we have to find out the 1's complement. After that we are adding 1. So the result is stored in register A. So the result is negative because A value is smaller, B value is greater. At that time when we are performing the subtraction operation, we may get the negative result. That negative result is stored in variable A. So for that purpose, the result is in 2's complement. Okay. So we may get the original result by taking the 2's complement on the result. For that purpose, we have to take the 1's complement plus 1. 1's complement of A is A bar. After that, we are adding 1. First, we have to find out the 1's complement of A. So, that is nothing but A bar that can be transferred to A, register A. After that, we are adding 1. Here, in these two steps, we have to find out the A bar plus 1 that can be transferred to register A. After performing the 2's complement of the result, then we are putting the negative sign before the result. negative sign before the result. So that negative sign of register A is AS. So we have to complement it. After that can be transferred to register A. Okay. After performing that, so finally the result is stored in register A and its sign bit is stored in register B. Next, whenever AS both sign bits are different, okay, so that means AS exclusive or BS. Go to this case. Sign bit of A is 0 and sign bit of B is 1. Sign bit of A is 1 and sign bit of B is 0. When we are performing the exclusive OR operation, we are getting the result as 1. So, after performing the exclusive OR operation between the sign bits of A and B, the output of the exclusive OR gate is 1. That means both sign bits are different. That is AS not equal to BS. At that time, simply we have to add the magnitudes A and B. So that is A plus B. After performing the addition of two magnitudes, the result is stored in register A. Whenever any output carry is generated, that can be transferred to extended flip-flop E. After that, the content of extended flip-flop E is transferred to add overflow flip-flop. Finally, the result is stored in register A and its sign bit is AS. In this way, we have to perform the addition and subtraction with sign magnitude data using this flowchart. I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really understanding this video, please subscribe my YouTube channel, Dibbela Srinivasa Rao. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. For better understanding of this course, go to this channel, go to the playlist called Computer Organization or Computer Architecture. Watch these videos and understanding the entire course. Thank you one and all for watching this video.